Good afternoon. We're going to be starting in a second. I'm just tuning my ukulele here. I do not promise to be at all musically inclined, but I think we will still have some fun this afternoon. I think the auto tuner is a little bit low on battery of the tuner. That's okay. It's all right. I'm gonna start with the tool that we're using today. It's called Google Science Journal. It's gonna help me to tune this. Ooh, a little bit flat. Let's see what we've got here. By the way, we're starting in a couple minutes. We're not started yet. Rudy, I am so glad to see you. It is, when we have these sessions that are that you can't see people. It's just me. It's nice to see people who I know. So I appreciate seeing my friend Rudy, and I see Jessica is here again. I appreciate you being here too. Thank you. Thanks everyone who's come here this afternoon. This might be your last session of the day. Thank you for agreeing to, or for choosing to spend it with me. I appreciate that. So we're at 329, and I'm gonna give you our first tool before I even start projecting. It's called Science Journal. It's a Google product. I know we started out the day with Microsoft with our Minecraft education. Then we got two Googly sessions in the afternoon. So I'm just gonna look up Google Science Journal to give you all the link to it. And while we're doing that, I'm going to point out Google Science Journal is being discontinued, but that's okay. There's a new vendor that's taking it up, and that's I know, Rudy, I know it broke my heart too. However, Arduino, and I know you know Arduino has taken it up. The Arduino version of the app is already available in the Apple App Store, or I think that's what's called, the Apple App Store. So I've installed it here. I used it with our Teachers College of San Joaquin students last night. I do want to point out, though, I gave you the Google Science Journal link because it has a link to all the amazing lessons that they have, and I hope those lessons are going to stick around for a while. But you should definitely check them out in the meantime. All right, so what I've got here is I've got Science Journal running on the tablet. I'm going to bring up the tablet a few times over the course of our session. See if I can make this a little bit bigger this way. Okay. And what Science Journal does is it gathers data using all of the reference. Oh, thank you for pointing that out, Rudy. Let me make sure you guys get that. Okay, try that again. There we go. So Science Journal, that's the website. It's going to have things like links to their lessons, but more importantly, you would want to go to your Google Play Store or your Apple App Store in order to get the app. Now, it's a free app. It even runs a limited version. It's a limited version, but it runs on a Chromebook too. I know I've been able to gather like light data using it. Works best on your mobile device because your mobile device has more sensors than a Chromebook. Chromebooks are cheap because they don't have that much stuff in them. So it will work on a Chromebook, but not quite as amazingly. Anyway, let's go ahead and get started. and we'll come back to Science Journal. We're just going to start talking about STEAM. So this session is called That Sounds Fun. It's just us looking at how we can get more STEAM into the classroom. And really at the heart of it is this problem that I realized, I realized it, that I'm sure all of us realized over the last several months, that it's hard to get kids hands-on activities to do, right? Because we're separated. But here's something that we're not separated. There's sound. Sound is still something that's hands-on that we can work with. And depending on how we set up our challenges, it can be there, it can be something that everyone can access, because there are things to make sound, if only to hum. I've got my ukulele. I've got this, but we don't need to have professional instruments. We can use an old jug of soda and make an instrument out of that. We're gonna work with rubber bands. We can use different size boxes and pans to make noise. We can give everyone access to hands-on STEM as we try to engineer something to make sound. So hopefully you've had a chance to go to the website. I'm going to give a quick once over the website, and then I'm going to jump into the presentation. All right, let's have that pop up. Here we go. So you'll notice this is kind of a asynchronous experience. I'm not going to go through everything that I put into the videos there, but I'm gonna go over some of it. And like here we're exploring sound, and here we're making things to make sound. And we have some tools that we're going to use. There's another Google tool. It's called the Chrome Sound Lab. So we'll have a chance to play with that. It has some really neat stuff there. And then we're going to finish with programming sound inside of Scratch and doing a little bit of producing. We're gonna sample. So that's going to be fun. And there's also an interactive workbook that I made for everybody. So it's right here at the bottom of the page. You can share it with the students. If you open it up, you'll notice that there are spaces for kids to be able to write in answers. So it's just kind of a tool so that you can carry this out with your kids, with your students a little bit later. So I'm going to go ahead and start up the presentation. You have the link to be able to refer back to, and I'll make sure to put it into the chat a few times as we go through the afternoon. All right, here we go. Go ahead and share this out. Not share it out, present it. There we go. That's what I'm talking about. Okay, so again, this session is called That Sounds Fun. It's here, it's a part of, or it's being presented as kind of a part of CodeStack STEAM. CodeStack STEAM being the computer science curriculum that is being developed by CodeStack and piloted right now in county schools, where kids are doing hands-on coding. So we're excited about that, and we wanted everyone to get to be able to try something that was like that. So I'm Steve Callahan. I'm the Educational Technology and Engineering Design Coordinator here at the SJCOE Fab Lab. I'm a part of STEM programs here, and there are some of my stickers. I'm a Google Innovator and a Microsoft Innovative, Microsoft Innovative Educator Expert. There, it's got a lot of letters there. Anyway, let's keep going. So we're going to do a few things. We're going to code, we're going to experiment, we're going to make sounds, we're going to look at patterns in waves, we're going to use a spectrogram, we're going to use science journal, and we're going to do a little bit of coding with Scratch. So it's going to be a fun time in the next 35 minutes that we have remaining. So being a little bit of a science nerd, I am going to throw out first that we're looking at a standard, right? We still want the kids to be learning from the standard. So here we want to use mathematical representations to describe a simple model for waves that includes how the amplitude of the wave is related to the energy in the wave. Okay, well that makes sense. And one of the great things about this is that we're going to be using tools to look at models, like different ways of understanding the data from the sound and just understanding what's going on in the sound. So I think this will be fun. So I do want to point out, I believe I put this into your references, but I'll tell you right here. Here we have links to 3 different instruments that can be made. These are links to the Exploratorium. You can see the link right there in the corner. Some of my, one of my favorite places to visit. The Exploratorium has the Sound Sandwich, which is kind of, I tend to think of it as being a harmonica. They have the memberphone and they have the straw oboe. I don't know if you have made those, but they're fun. They're simple ways for us to help kids make sound. We can do that in a lot of different ways. I went ahead and went with just designing something myself. We do a lot of this here where, we draw something out. So you'll notice I sketched out this idea for like something flat and different distances that I'm stretching a rubber band. So I made this with the 3D printer because I'm here at the Fab Lab. We have a lot of 3D printers. So it was the quickest way for me to go about doing that. But I could have just as easily taken a board, cut that, and then put some screws at different distances and stretch the rubber band over that. But here it is. Here's my little rubber band harp. I'm gonna get this close to the microphone. I'm hoping you can hear it. So that's the long string. Not as long of a string. Okay, so my tone is changing depending on how far I've stretched this. Now, I was mentioning how we have Science Journal, and I was able to record some of that. We'll get back to it. But we can test out or make different sounds just with different materials. All right. So one of the things I want to start off with us looking at is the spectrogram. So I'm just going to go ahead and click the link. Click that again. Oh yeah, I remember. There we go. All right, so it looks blank, but I'll show you how it works. So what it does is it shows, oh no, I don't see it. Let's try that again. All right, so depending on permissions on the site link. Christina, could you tell me, what is it that's, are you not able to get to the website, the Google site with all the references? Huh. Okay, I'm going to double check that right now because we used it earlier today. Is there anyone else who's not able to get to the? Okay. Let's see. Yeah, it says anyone with the internet could open. Yeah, sure. Glad to send the link again. I'm gonna try and figure out what's going on. But there's the link right now. Oh, I don't think that's on our end. I think that your school is, or maybe you're at a school and it's not allowing you to go to the Google site. Yeah, one participant is saying that it might be a firewall issue. I'm sorry about that. I'm gonna keep going, but I'm gonna keep trying to think about a way to help with that. Oh, you got it. Okay, great. So I'm gonna go back to the spectrogram. So what the spectrogram does is it kind of shows me how different waves appear. So notice as I'm speaking, I'm getting different sounds. I'm gonna do this more than one time today. High note, low note. So notice it shows up at different heights depending on how high the pitch is. So let me send a link. I'm gonna give you a link to that. It's also in. It's also shared out. Here we go. Apple Feed. I'll point out when you use that workbook, I think if you click on the workbook, it'll allow you to click and go to it. If you do have trouble going to the links in the workbook that I gave, what you want to do is be in present mode, because the way I designed it, all of that content is in what's called the slide master, so that kids can't move it around. So the kids can edit the text box that's there for them, but they don't move around all the stuff behind it. But to follow the links, you want to click present. That's all. Okay, let's keep going. So I can get different sounds to show up differently with this. Kids can experiment. Not going to go through the whole thing, but it is there on the workbook. All right, next step. All right, so we have another thing that we want to kind of play with, because this is all about the kids kind of experimenting, seeing what can make sounds, what works for that, what doesn't. And so here we are. There's something called the sound wave visualizer. Let's try that out. Now, I particularly like the sound wave visualizer because you can see the compression of the particles together and their separation. In fact, you can see a wave kind of flowing along differently depending on which note it is. And if I zoom in, what I'm seeing is that a wave is this shifting back and forth of individual particles, but the energy is flowing through that medium. So we can see the energy flow through the medium in the form of this compression. We can see those compressions moving from the bottom of the screen to the top of the screen, but it's not each particle moving from the top of the screen to the bottom of the screen. They're just moving back and forth. Anyway, nerding out a little bit with sound. Now, I do want to point out, just as you're using the workbook or trying out the lesson with students, I'm only using 2 of the Chrome Music Lab experiments here. There are a ton to try out and have fun with. But we don't have enough time to do all that because we still have to try out Scratch. All right, moving on. Now, Google Science Journal is amazing. I'm going to put a link for you there for Google Science Journal, just in case you weren't here before we started. And I want to give you a chance, just a moment, to download an app. So you can try out the sensors. So we're just we're gonna try and, I only want to give us a couple minutes to try this out, but while you're downloading, I'm gonna play a few seconds of their video because it's a great video.
Our physical world is full of wonder. It's a constant source of thought-provoking questions. And it offers us observable and measurable information to help understand and answer these questions. Light, sound, and motion all contain answers to how the world around us works. And Google Science Journal allows you to observe, measure, record, and document this information, all from your phone. Gather and document science experiments from the world around you using sensors already in your phone. Graph.
Okay, I'm going to stop there because every moment is precious. I'm sure you got the point from what they were saying. Let's go ahead and try it out. It is so great. So here we go. I'm going to exit presentation. I have Science Journal up here. Notice I've chosen this squiggly line right here on the app. So one of the great things about it is I can have students to make observations. They can type in their thoughts, what they see. I can choose the camera, or I can choose this little squiggly line for sensors. Now, I'm also going to point out, I'm just going to leave that for a second. This little orange icon here is the new Arduino version. It's exactly the same. The only difference is that it doesn't have kind of the Google Cloud, the Google Drive functionality built into it, but you can still output what you work on to a PDF. So yeah, no loss there. Okay, Rudy, thank you for asking that question. So there's a slide of Google. Let me show you the website. So here's our website for this talk. I'm going to scroll to the bottom, and here is the workbook right there for you. Is it showing up to you, Rudy? Okay, great. So I'm going to really quickly demonstrate how Science Journal works. So you could have used the Google one. Right here, I have some data. This was when I was trying my little 3D printed harp right here. You can see there's like different heights, and the different heights are coming in at different notes that I was able to play from plucking those rubber bands. But for simplicity of seeing it, I'm gonna click here. The icon is a little bit different. It looks like an LED on the Arduino version. That's the same functionality. And I'm going to choose the musical notes. I'm going to do that same thing again. High, low. Okay, so notice the graph is at a different height depending on the noise. So let's try this out. Here we go. Okay, so different heights depending on the sound that is created by the instrument. Now, that's going to be handy in a minute. We're going to use it with Scratch. So I'm going to do a quick introduction to Scratch. I'm going to point out that if you watch this video, I also take a little bit of time just to kind of explain how musical notes work on sheet music. The whole idea being, of course, lower note is lower on the staff, right? Is that right? Anyway, lower line for a lower note, and all good boys you find. Anyway, I forget as I'm saying this, but we go over the note for each line, which is handy because we're also going to be looking at that as we are coding in Scratch. So I'm gonna bring up Scratch. We're gonna try out coding a little bit of music with Scratch. Okay, so there's the link to Scratch, and I'm going to share it out to our screen. There we go. All right, I'm just going to go ahead and sign in. So if you're not familiar with Scratch, it is a product of MIT. I want to say it's the Lifelong Kindergarten Lab. They come with amazing stuff. Actually, the Google Chrome Music Lab was a product of one of their scientists. So it's just a great tool for students. It's free. And I'm just going to go ahead and click create. So you'll notice right here, we've got Scratchy the cat. And just to go over the basics of Scratch, it starts with just motion. You'll notice we have a category here for motion of blocks. So I'm going to say, I want it to move 10 steps. I'm going to click. Notice what I'm doing here is I'm changing the location. Notice X and Y location here. I'm changing the X location of the cat. Okay. Now, clicking on the block doesn't feel right for coding, right? Like programmers don't, well, I guess sometimes you do, like say if you're working in a shell, you might directly type in a single command, but very often, you have an interface, you have a button you press that makes something run. So I'm going to go here to events. I'm going to say, when the green flag is clicked, this one, run. Oh, hey. So now we've got it moving. That's fine. But one of the things that's useful in computers is I can program them to do things over and over again, so I don't have to keep doing whatever it is. So I'm going to add in iteration. I'm going to say, I want to move forward 10 times. So I'm going to go ahead and click that green flag. All right. And from this, we can start to create a program. I like to point out that Scratch has the basics of coding in any first year programming class that you take in college. We have conditions and iteration and operators and logic. We've got everything. So I could even, I'm just going to go in and make a background. Paint. Put blocks. Purple blocks. I'm going to tell it to move forward, but as it moves forward, I'm going to build in some logic, like if then. I'm gonna say, you know what, if you sense, if you are touching the color purple, then I'm gonna have it to meow. So I can go to sound, and going to sound is gonna be important again in a second. All right, I'm gonna go way back here. I'm gonna hit once. Take that down to 5. All right, I hit once, nothing happens. I hit again. Oh, it meows when it hits the purple. We can come up with some pretty complicated and useful tools just using Scratch. But our interest right now for today is not the motion properties of Scratch. It's really the sound abilities in Scratch. So you'll notice here in the bottom left-hand corner, we have a bunch of extensions. And I cannot say enough about how much I like the extensions here. There's some amazing stuff that we can get done here. Among them, translation. Like Google's translation ability can be built into a student's Scratch program. So they can do some pretty cool stuff. We can also have text to speech. So a student can have it to say stuff, to translate things. We can make some pretty cool tools here. Another thing that I want to point out is really powerful is that we can build in Lego robots to our Scratch creations. In fact, we have some Scratch inside of our CodeStack curriculum using the microbit, because we use the microbit a lot. It's a cheap, versatile tool. They run somewhere around $17 a person, a kit, and well, anyway, it's like $17 a kit. They're cheap. Part of one of the things that we wanted to make sure when we created the curriculum was that it was cheap enough that it could be implemented in schools, and everyone could have something hands-on. So just to point out, the microbit is I love Legos. Don't get me wrong, but we have them here, tons of them here at the lab. But also the microbit is a great solution as well. Okay, I see something in chat. Make sure to respond. Oh, Rudy, I know. I saw that online. Rudy just chatted to me. Microbit 2 is coming out at the end of the month. I'm super psyched about it. Can I say the one thing that I don't like? They realized, oh, it'd be really cool to have capacitive touch built in. Yay. It'd be really cool to have a speaker. Yay. Really cool to have a sound sensor. That's all brilliant. But why are there only red LEDs? Why didn't they go ahead and add color? They had, anyway, whatever. I would have, if they had asked me, I would have said it would be nice to have color too. But anyway, we can do some really cool stuff with that microbit and the microbit 2, which is coming out soon. Thank you for pointing that out, Rudy. So I can build into my program any one of these functionalities. I'm gonna go with music because, you know, it's the topic of our talk. All right, so you'll notice a category that was not there before is music. And what I can do now is say, okay, let's play a note. So I could say something like, when I tap on Scratchy, that'd be an event. It's gonna play a note. Let's try. I can choose different notes, right? Depending on what I read on my sheet music. Yeah, it's every good boy does fine. E, G, B, D, F. Those are the bars. Anyway, so we can program a tune on in our little Scratch program right here. Now, I actually already did something. I'm gonna say, I'm gonna go to my stuff. One of the great things about Scratch is that you can, students, well, you have a database of all the stuff that you've made. Just gonna leave because I don't really care about that one. So the first thing I'm going to show you is the music that I coded in the video that's there in the workbook. I'm going to click See Inside, and you'll notice right here, I've coded CC, so 60 is C, GG, AA, and then G. So, oh, right here. Let's try it out. All right, so we can start to program our music right there. You'll notice when you see the video, we start out going through coding this half of it's Twinkle Twinkle. I'm guessing everyone knew that. This first half of Twinkle Twinkle, and then the students can try out coding the other half of it. So that's just coding the music if we use the music tool. But more interestingly, right, because we were doing a little bit of engineering and looking at our data that we were able to gather from Science Journal. You'll notice, by the way, Science Journal, we looked at the note capability. We also, and there's some questions in the workbook, are looking at amplitude, right? Because that's a part of the standard. There's an amplitude sensor in Science Journal, and we can have the students to draw the wave, like a representation of a wave, depending on the different sounds. So you'll notice that it kind of walks you through that when you're in the workbook. Can we go back to my stuff? What I did was I sampled for my harmonica. Now, again, you remember we looked at a Science Journal and how we could gather data from a sound sample, right? So what I did, I'm just gonna go ahead and see inside. What I did was I went to Sounds, and I want to, sorry, sound, go here. And when you click here, you can record a sound. Now, easy enough. I'm just gonna go ahead and click on record. Hi, everybody. Thanks for being here. Now I can cut this and go to about here. Let's play. Hi, everybody. Thanks for being here. All right, and then I can save that. And I can tie it to a sprite or to an event, which is fine. What I did was I recorded different harmonica sounds. Here's one. So what I did was I recorded it from the harmonica, and then it's a little bit easier to record and then play it for Science Journal and see what note you're hitting. And as I did that, I then moved those notes around until I had, D, E, F, G, and A all together, so that now so that we've made our and as I'm doing that, I notice I want to make a couple of these a little bit louder. Anyway, so we're able to make our instrument. The students could engineer a tool in Scratch to be able to play the sound of jugs of water or of a rubber band harp or whatever it is that drums made from cardboard boxes. Whatever it is that they're able to make, they can. So I guess I just kind of wanted to walk people through just trying this out with the last couple of minutes that we have. I think I've got 3 minutes before we start our Q&A. Here we go. All right. Just a couple things I did want to point out. If you go to through the workbook, it does point out looking at high-pitched and low-pitched waves, making those models, looking at high amplitude and low amplitude waves, trying to understand those models. And then we have our, what's the right word for that? Our little lesson on sheet music. Are there any questions with Scratch? I wish we were here so I could see how you guys are doing. Could I get any feedback? Have people been able to get to the Scratch website? Is there any trouble with it? Oh, good. Okay. Thank you, Rudy. Oh, good, good, good. Thank you, Denise. I'm glad to hear that. Thank you, Laura. So I'm going to go back to here. All right, so we're at 409. Let me see, is there anything else? No, there isn't. Can I answer any questions? Because we're now in the question and answer portion. Do people have any questions about Scratch or about coding with sound or about engineering sounds that I can answer? And yeah. Okay, thank you, Karen. Good, great, thank you. As we're on the way out and finishing the day, thank you all for being here. I'm going to point out there's a lot of cool stuff that we can do with sound as we're recording that you might want to try out. So let me see. Hello. Oh, hello. 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 Whoa. Hello. Hello. So I can mess with the sound more and more. The kids can kind of make their instrument and make it something that you would never hear in reality. They can design an instrument here and try to engineer it to be like that. Christina, I'm glad you're able to get to the site. I'm sorry to hear that that gave you so much trouble, but I'm glad you were able to get there. I do want to point out this is the third of the sessions that I got to present today. So if you want, you'll notice when you go back here to home, we had a few other things that we went over: AppScript coding, and also right here we spent a little bit of time with Minecraft. Those are worth taking a little bit of a look at. A lot of fun. The type of engineering mixed with coding and exploration that our the CodeStack curriculum is built on. Thank you so much, Lillian. Thank you so much, everyone, for being here. I'm sticking around to answer any questions that you might have, either about coding or engineering or maker spaces, 3D printing, any of the technology that we talked about during the presentation. I'm glad to take any questions. And if not, it's you're welcome to stay. But you're also, I hope you have a great weekend.